Divyesh Kumar Patel. I'm really pleased to introduce him, who's going to talk about chaos testing for resilience. Divyesh has over 18 years experience in the industry. He's worked in various roles and has developed a strong specialization in testing technology. He's got extensive knowledge in research, onboarding, implementation, integration, and migrations, which he puts to good use, and where he manages and supports numerous testing tools to ensure the quality of applications. He's managed many successful end-to-end software testing projects. He keeps up to date with emerging technologies and tools, conducting extensive research to optimize testing processes, and keeps his team ahead of the curve. Most important. Sorry, pardon me. Divyesh, over to you, and enjoy yourself.
Okay, thank you all. That's great. You covered, everything about me. One thing I want to add here is I'm more close to different testing tools. I have evaluated almost like 30+ testing tools throughout my career, and I have onboarded numbers of tools that used on test case management, performance testing, to automation testing, mobile testing, as well as the visual testing. As well as I'm a part of advisory board members of numbers of testing tools as well. I'm located in United States of US, like basically USA. I'm working as a cloud engineer in one of the financial institute. Let's move to the chaos testing. So why chaos testing, right? Okay, I'm seeing some of the in between. Okay, so why chaos testing, right? So ensuring the reliability and resiliency of complex distributed system has been more critical, especially with the RTO and RPO of the application, right? Each of application have the requirement of RTO and RPO. So any event happen, then that application needs to be recovered within those predefined RTO and RPO. To achieve that, chaos engineering has become a popular method for business to test the resiliency and reliability of the system. Part of this one, based on the Gartner analysis, job posting and the adoption of the chaos increased by 200% within a couple of years. Part of this session, I'm going to share the information about the principles of the chaos testing or engineering, advantages of that, also the framework that I have implemented in my company and my organization. Using that, the framework is contained with AWS Resilience Hub, AWS FIS, Load Runner, that help us to make our systems resilient. Here I'm talking couple of tools, but I'm not really saying you required to use those kind of tools. You can pick any tools that good fit for your organization. So moving to what is chaos engineering or testing. You may heard like engineering. I'm putting as a testing because I'm more focused on the testing part of it. It's not just the engineering, right? So chaos engineering is different from the traditional testing. Chaos engineering is more focused on the proactively testing the host infrastructure, injecting the failure scenarios on the system. Our traditional testing is not enough because unit testing is more focused on the component level testing, that where we isolated and ensure the functionality meets the expectation. The same way, like a functional testing is more focused on test to assure the expected results, right? But chaos engineering is more to help to improve the resiliency, improve the performance. It's helped to expose any blind spot using this different monitoring. Overall, chaos engineering helped to reduce the unplanned downtime by 20%. This is based on the AWS research. And whatever the facts I'm telling, it's based on the Gartner or AWS research. Okay, so since now you know why we are doing, so we are moving to the what is the principle or fundamental behind this chaos engineering? What is prerequisite, or what is required to do the what all the preconditions or a prerequisite for chaos engineering? So for chaos engineering, we need basic monitoring, because this is all about, you will put the failures on the system and you want to see how the application behave, right? So basic monitoring is required. This is without monitoring, you cannot do the chaos engineering. It's similar, go with like a performance testing, right? If you want to do performance testing, you cannot do performance testing without monitoring. You can do, but you cannot achieve the goal, right? So uh, basic monitoring is the prerequisite. Organizational awareness, right? uh, this is like, when we say like we are going to inject some failures in the system, right? um, Organization will be say, oh, you cannot do this because it will be impact to your end user or end user customers, right? So organizational awareness is required. We need to educate the teams. And also it's like, when we want to do the chaos engineering, it's not a one team effort. It's like multiple teams need to involve. It's your application stakeholder, your testing teams, your SRE teams, your cloud teams. So it's like a multiple teams effort, this one. So organizational awareness is important for chaos testing. Real world and events and faults. Here, like, you just don't want to just go and do some failures testing, right? Basically, you don't just want to go and do some testing. Here you want to do the testing that gives some kind of outcome, right? So you will inject the failure. Those are known failures that you can see from your previous experience. Basically, some of the event happened earlier and it's broke down, or it's create a major issue on your application. Those kind of scenarios you can take part of your chaos engineering or chaos testing, and you can reproduce those issues, and that will help to make your application resilient. So here we just not want to turn off some system, right? Basically, chaos engineering, what it does is like, basically it's inject the failures. It will bring down the servers. So we just don't want to bring down the servers. We want to create a real world scenario when that kind of things happen, how our application will behave, right? So so prerequisite is like when we want to create a real world scenario, and because of that, I'm using load runner to generate the real world traffic and doing that fault injection. And I will talk more about in my framework that remediating and finding. So fourth step is like part of the prerequisite is remediation and remediating the findings, right? So part of the chaos testing, you will find some issue. Maybe you will not find. If you not find any issue, means like your application is resilient enough. But if you find any issue, you need to make the priorities and fix that issue, right? Because as you find the issue, if you not solve the problem, then your application it will be not a resilient enough, right? The goal of chaos engineering to make your application resilient. So as you find any issue, you need to remediate that issue and do that chaos engineering again to make your application continuous stable. So this is all like a prerequisite, but the principles. So this is like a 4-step really process, and it's cycle. It's not a one-time activity. This is kind of continuous process that you need to do continuously to achieve the desired goal. So starting with a plan, right? So in plan, you will decide what system you want to attack, or which system you want to test part of your chaos engineering, right? Which application or workflow you want to test. And those workflow have which application dependent on that, or associate machines or associate servers for those. Once you have that predefined workflow, like what you want to test, right? Then you will do the next step is like experiment, right? So experiment is nothing but you will create those fault injection scenarios. So for example, I'm just giving the example of like your application is hosted on AWS. Now it's using the EC2 or ECS, like container services, right? Then you will plan to inject those failures on those particular systems, that's nothing but your experiment. Like basically you will say, I want to restart my EC2s in between while we are generating the load on the application. And while this happening, you will see like how your application behaving through the monitoring. So that is like experiment. Like analysis is nothing but the monitoring. While you are executing your test, you are analyzing and like looking at like how the application is behaving. And mitigate is nothing but whatever you find part of your analysis, you will resolve that issue and you will do the continuous process. So principles have like a four major point is like plan, experiment, analysis, and the mitigation, right? Now let's move to the tools. So as I said, like, here I put like a numbers of tools, but again, it's like some of are open source, some of have a commercial licensing required and all, but some of those are what I have put here. It's like a 7, but it's like a numbers of tools available in the market for chaos testing nowadays. And pick the tools that is best fit for your requirement, right? I have closely worked with a Gremlin, Chaos Monkey, Chaos Toolkit, as well as AWS Fault Injection. But this is all the popular tools. And as I said, like some of are commercial, some of are open source. So pick whatever the best fit for you. In my workflow or my framework, I have used the fault injection simulator. It's called FIS, and I'll give more information about the AWS FIS here. So what is AWS fault injection simulator? Okay, so this is like a recently really got really popular, and if you are attended or your any of those AWS reInvent, then they have shared this information as well. So AWS Fault Injector is a fully managed chaos service that generate the fault injection on the systems. So similar way, like any tool you pick, they all do the similar way, right? So this is nothing but this tool can help to generate those chaos, right? Basically, it help to stop the systems like the servers, right? Or create the network traffic, or create the task killing kind of processes. So it's help to create those kind of use cases. So all these tools like do the similar way, but it's different companies support different tools. But if you are on your application workload in AWS, then this is the one of the good fit service that you can easily enable and you can utilize. So it's called FIS. It's known as the FIS, but its full form is Amazon Fault Injection Simulator. This one have like a 3 component. It's like action, targets, and experiment. So action is nothing but what you want to do with using this FIS, right? So basically, you can say I want to restart my restart my EC2. I want to kill the process on ECS, or you want to kill the S3 bucket, or you want to generate the network traffic, or you want to create whitelisting, IPs whitelisting. So you can do like a numbers of actions that AWS FIS already have predefined that you can pick from the list. And then you need to pick the target, right? Target is nothing but which system, right? So basically the IP of that particular system. So like for example, EC2s, right? So EC2s have RNR number, or it's like identifier numbers that you can pick. So the action you pick, then you where you want to run that action, that's a target. The combination of these two is called experiment template. Okay, so when you want to trigger that chaos testing, you need to use that experiment template ID to trigger that action and to run those actions on the target. So for FIS, these 3 components are there, like action, target, and experiment. Once your experiment template is ready, you don't need to go back to the action or target until and unless you need to really edit those. But otherwise, it's like basically action and target cover all your experiment template, and from outside, you will just use the experiment template to run that. So moving to the next step, like here, right? Chaos testing is not about the breaking things without purpose, right? It's about breaking things in controlled environment and through the well-planned experiment in order to build confidence in the application, right? So chaos engineering will break the system, but it's not just the breaking the system. We will put those in a controlled environment, so it will, it will be a planned experiment, and it's help to build the application confidence on the application. So this is like kind of a step-by-step process how we can put this in your systems, right? So setting up the expectation, right? So as I said, like it's not like a one team activity. It's like you need to engage multiple stakeholders, and you need to basically share all this knowledge with them. You need to identify what is the outcome, right? Basically, why we are doing, what's the goal to do that. Because it's not like easy activity. When you say like we need to do this kind of experiment, the organization will be not ready if it's not fully aware what will be the impact, what will be the outcome. So don't just go and do, right? You just need to explain the organization what's the process, how you're going to do. You need to do this as a proper planning way. Select target workload, right? You should not do like direct production. Earlier Arun said do not do lot of testing, but he mentioned that like you should do but not go crazy kind of, right? Like minimal, whatever really required kind of. So think about that way. But at the same time, we need to do with lower environment. Let's start with a dev, then go to the model, and then go to the production. With that also, we need to focus the workload that is less impacted first, right? Because initially you are just playing around. So when you're picking the target workload, pick the workload that have a minimal impact. Then when you're planning to run, before that, just make sure that applications and application is healthy, right? Basically, you don't want to be application should be active and running. We don't want to see like some of the known issue already there. So those issue needs to be fixed before that. Check your run book, playbook, right? Then run the experiment. While you are running the experiment, make sure you will all your SMEs are available, because while you are executing your experiment, the end goal is you want to fix this issue if you find, right? And if you are all the stakeholder on the call and they see like what's the issue happening, and they may know already what is the fix kind of, right? So it's a multi stakeholder approach, or multi stakeholders engagement required, and we need to make sure those are available. And when you do the game day, right, we need to make sure they all available, and based on that only you should plan those game days. And as I said, like it's a continuous resiliency. It's not like one-time effort. So start with the individual experiment in a dev, then do the game day in a prod, because end goal is to do in the prod, right? But the way we are saying is to start with a dev, do some practices in model, and do that in a prod. Also in my next slide, I will going to talk more about step-by-step process on that too. Let's move to the next slide. Oh, sorry. Okay, so this is my framework that I'm using, and you may see in soon in my other blogs, as well as I'm working with a different blog in AWS as well. But so overall, this is my framework where I'm combining our load testing. Here you see like actually 4 different things. One is like AWS Resiliency Hub, that here. You see here like AWS Fault Injector Simulator on the FIS that we talked. Here you see the CI/CD pipeline where we are using GitLab and the load runner for load testing. As I said, like this is all different tools I'm using, but it's no, you can from here, you may take the concept. It's not like, you can pick any load testing tool. You may use any CI/CD pipeline, but at the end, you can use the similar workflow for your chaos testing, if you like this workflow, right? So how my framework is work, I can explain that quickly. So AWS Resiliency Hub is like a well-architected services. So what this does is like in AWS Resiliency Hub, you will add your AWS hosted application. It will scan your application and it will recommend it some changes. Those changes are likely kind of do some configuration changes to make your application stable or sustainable. Similar way, it will say like add multiple, add a load balancer. If you not have, it may say like add add like more resources, right? So those kind of on configuration changes, it will recommend it based on application scanning, and the application team needs to apply those changes. Once those, like this is for us, like in our framework, this is the first step. Once this step is done, this is like now we know like our application is stable, and we know like our application is resilient enough. But now we will go to the next step where we generate the load through the load runner on the application. And at the same time, we will inject the failures through the FIS, right? So this is like these two activities, like a load runner script and our FIS experiment, those which will, created on the side. Once we have both ready, what we will do is we triggering through the GitLab pipeline. So my GitLab pipeline will trigger the load test, and in between we will inject these failures through the FIS. Okay. While this whole thing's happening, we will monitor through the CloudWatch as well as the load runner native monitoring. So what we will get out of it, right? So with CloudWatch, we will see how the system is behaving, right? Is that like, when we stop the instance, is that automatically it's auto scaling or not, right? Is it automatically recovering or not? That we will watch on the CloudWatch, or application insight, or Grafana, like this all different monitoring tool we are using. On the side, the same time we are on the, as a load performance engineer, we will watch on the load runner side, like is this application is giving the proper response time or not. So it's the way this framework is, I have combined the performance testing and chaos testing together. Because the way people think is like, this two separate activity, but typically most of the organization have performance testing and they have already script ready. What we did is like we combined that chaos engineering part with it, and we just come up with a new framework where we are doing our regular performance testing, and in top of that we are adding the chaos engineering. And since we have all this predefined monitoring set, we will see like how the overall application behavior as well as the system behavior happening, right? So as I said, like we are using here multiple tools, but again, if you are using any other CI/CD tool, same way you can trigger the load runner, or you may not using load runner for your load testing tool. You may use any other tool, right? But at the end of the day, right, the plan here to use the load runner is to generate the load on the application, and same time inject the failures. Now, injecting the failures also, you can use any fault injection tools. As I mentioned earlier, there is a number of tools available in the market. Any of those tools you can pick. Moving to the next section. So how I have implemented, or how you can implement this one, right? Because as I said, like when we say like a game day and production, because when we say like a chaos testing, people think only in a production, right? We cannot go directly production, and we all in a testing area, we know like it's when we say like production and testing in the production, it's scared, right? So when we approach this in any organization, right, we'll say like, okay, we'll start with a dev, right? We'll bring the chaos testing in a reality, starting in practicing in a lower environment and adopt it incrementally, right? We may start with, maybe targeting only one service, basically like say EC2. We'll use just the where we see like a limited workflow, or maybe target only one workflow or only one API service, right? So that's why it will not impact to anything else. So maybe, start with a small. Once that you are comfortable, you move to the model, right? Where you are now familiar with the chaos processes, right? Now, once you are, in model, you are validate steady state behavior and then move to the production, right? So model is again, right, like a dev where you are just practicing with a smaller group. Now we go to the model with a dev, right? Now we are moving to the model where you are, bringing more practices, like basically you may expand more services with chaos testing. Also, you may target bigger workflow, right? Once you are, comfortable in model where you do all, end to end, then you will go to the prod where you do the actual game day, and that's the actual, end goal. This is the goal for chaos testing, because we want to do in the production. You do all day like in a dev and model, but it's not give the outcome that we want to do from the chaos testing, right? The target chaos testing is like basically we want to make our production system resilient enough so anything happen, it will not cause any issue to the, the user will not notice any uh, downtime. That's on end goal, right? So we need to do in the prod. So do the game day at a production environment. Again, as I said, like we need like a multiple teams needs to be available. As I said, like right personnel is available to run the test, handle failures, and discuss the outcome in the real time, right? If you see any issue, we need to fix those, and we need to go from there. Okay, so seeing this, like, it's like a number of advantage we have with a chaos engineering or testing. You may already using chaos testing in your organization. If not, this is the number of, and you may already, if you are using, you may already find this all the different benefit. But the chaos engineering help in the preparing and educating the engineering teams to the actual failures. This is nothing but we are, proactively validating our systems. So we are doing the practices, and from that we are creating run book and playbook. So when really any issue even happen, you have already practices, so you know how to solve that problems, right? Overall, with these practices, we improve the system performance and resiliency. It's expose the blind spot, right? We will using the different monitoring, and we are making sure our systems are resilient enough, even though still like there's a chances, right? Like where we see the issue, but our run book and playbook will help if it's any kind of issue happen. Increasing end user stakeholder satisfaction, right? Like if your application have a zero downtime, obviously your stakeholders happy as well as your end user will be happy, right? Your application will be available all the time. And that's like, any organization wants to do that way. So also, this is really help if you see like a DR testing, right? Disaster testing. So we are introducing this is like a part of our disaster recovery exercise as well, because this is all going to hands on hands. It's come up with a different title, but it's all really it's the same thing. Like we are doing performance testing from for very long. Chaos testing introduced recently, but this and disaster recovery testing also happening for along, right? So this is like a combine everything in a, basically it's going everything hands to hand. Also learn how the system handle different failures, right? This is again, it's a redundant way, like basically how the chaos engineering work, and with this all practices, we know how to handle different failures. Overall, improve the architecture design to handle the failures, right? This the chaos engineering practice help to improve our application architecture and design to handle any failures. Yeah, this is pretty much, but at the end, I want to say like chaos testing is crucial methodology for testing the resiliency and reliability of complex distributed system. It's not a one-time activity. I just want to make sure it's like, like it's not a one-time activity. It's required to add in continuous process to achieve the desired outcome. That's pretty much from my side, Paul. If since we have time, if anybody have question, we can, take it.
Thanks very much, Divyesh. You finished exactly on time.
Yeah.
Well, no time for questions. However, there is one. Let's put it to you anyway. This is from Richie Pleaseby in the chat. Most organizations don't even do fundamental failover, disaster recovery, the testing that you're talking about, the basic stuff. So chaos is, in Richie's terms, way out there. He's interested in how you convince business or clients to agree that you should do it. What's the selling point that you would push?
Yeah, so nowadays, like, all the organization, even like, upper management, right? They are aware with chaos and the benefit of it. It's all about to approach them, going with this, all the different benefits, right? And DR testing, as I said, right? Like it's DR testing is happening manually that we have seen so far, especially in our organization and all. So this is something even I approach in this year, and this is something, I got really positive, response, and they are really excited. And if your organization is not doing, I can say maybe use the Gartner report. You may use the AWS, responses or their analysis, and that will help you to, to move your organization as well in the same space. And as I said, like we are not doing really anything differently. We are doing already load testing and performance testing. Yeah. We are just adding few things with that. It's all about, showing the benefit of it and start with a dev model and go to the prod.
Okay, I have to close it there. Once more, thanks you so much.